Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of lateral surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a right circular cone with base 40 millimeter and axis height 55 millimeter. Now this right circular cone has been cut by a section plane as it is shown in the figure below. So we can check 8 millimeter from the right hand side corner. So we are going to draw the starting point of an arc over here. So from this point we are going to draw an auxiliary inclined plane at an angle of 30 degree over here, and the second cutting plane. Here we have got an arc of 22 millimeter radius over here. So this is the radius of the arc, which is equal to 22 millimeter. So we are going to start this arc from the right hand side slant generator of this particular cone over here. So from this point at a distance of 22 millimeter, so we'll draw an arc wherever this arc is going to intersect this auxiliary inclined plane, which happens to be inclined at an angle of 30 degree with respect to the horizontal plane. So this point of intersection we are going to obtain over here. Now corresponding to this truncation, now we are required to develop the lateral surface of this truncated cone over here. So let us proceed with the evaluation of top view and the front view orthographic projections corresponding to this right circular cone. So as the observer is going to look at this cone from the top, we are going to obtain circular projection corresponding to the base of this circular cone onto the horizontal plane in the top view projections over here. And we know the dimension of this base over here. The dimension of the base happens to be 40 millimeter. So here we have got 40 millimeter base. Now we have divided this circular projection into the 12 equal parts over here, so that each sector will have the included angle as 30 degree over here. So all the 12 points of the base, they have been appropriately obtained into the top view projections over here. And now we have obtained the access points. So the access points, they happen to be O and O1. O point corresponds to the apex point of the axis, whereas O1 point, it will lie over here. That is, it will lie onto the base of the circular cone corresponding to the axis over here. So having obtained the top view projections of this cone, now let us obtain the front view projections of this right circular cone. So the 12 points of the base we have obtained onto the XY reference line in the elevation projection view over here. And once we know the access points, so now through these access points O and O1, we have drawn the axis projections into the elevation projection view. Now we can mark the O1 dash point, which is access point corresponding to the base of this cone over here. Now we know that the axis height of the circular cone happens to be 55 millimeter. So once we mark the axis height is equal to 55 millimeter, so the location of the apex into the front view projections, it will be obtained. So point O dash corresponding to the apex, it has been obtained. And now we know that we need to join O dash 1 dash and O dash 7 dash slant generators of this cone. So we have joined these two generators to begin with, because these generators O dash 1 dash and O dash 7 dash, they happen to define the boundary of the cone into the front view projections over here. Besides this, since the top view of the slant generator O1 and top view of the slant generator O7, they happen to be parallel to the vertical plane, so the projections of the slant generators O dash 1 dash and O dash 7 dash into the front view projections they will reveal the true length of the slant generators over here. Whereas the remaining 10 slant generators which we are going to get corresponding to these 5 pairs of points over here, which are projected onto the elevation projection view on the XY reference line. So once we join the remaining 10 slant generators, so we obtain that all of these 10 slant generators, they happen to be apparent lengths of the slant generators into the front view projection over here. So now we know that there is a cutting plane which is going to start from 8 millimeter offset from the right hand side corner of the rim of the base over here. So from point 7 dash, we have marked a distance of 8 millimeter. Now an auxiliary inclined plane inclined to HP at an angle of 30 degree now we have drawn from this point, which is located at an offset of 8 millimeter from the right hand side corner point 7 dash over here. So now with this point as the center, we'll open the compass is equal to 22 millimeter radius. And once we open the compass 22 millimeter radius, so this will be the needle point of the compass. Once we start intersecting different slant generators of this cone from the right hand side over here, so we are going to project this arc with radius 22 millimeter till this arc intersects with this straight line auxiliary inclined plane over here. So this way, using these two cutting planes, we have been able to intersect or remove this much portion of the cone over here. So now we can join the remainder solid over here. So now let us first of all proceed with the evaluation of development of lateral surface of the untruncated or uncut cone over here. So to begin with, we have already discussed O-1- and O-7-. So these are the two slant generators lying on the extreme or the boundary of this cone in the front view elevation projection view. So these two slant generators, they are represented as true length of the slant generator in the front view projections over here. So now with O as the center, radius is equal to O1, which is equal to O-1- or O-7- over here. So with this radius of the true length of the slant generator, we have drawn an arc over here such that onto this arc we are going to obtain 12 points corresponding to the 12 sectors which we have identified onto the circumference of the base of this cone over here. So now we are going to measure the distance between points 1 and 2, and corresponding to all these sectors, this distance will remain the same. Why? Because the included angle for every sector happens to be 30 degree. So whatever will be the length of the distance between points 1 and 2, so the same distance we are going to obtain between the successive points which are going to lie onto the base over here. So the 12 arcs we have marked onto this particular arc which we have drawn corresponding to the true length of the slant edges over here. So now we can join the apex point O with all the points of the base over here. So this is the development of the uncut right circular cone over here. Now let us evaluate different points of intersection which are going to lie alongside this inclined straight line cutting plane and alongside this circular sectional plane over here. So let us start with first 2 points over here, that is Q dash and Q1 dash. So we know that Q dash and Q1 dash, they happen to be the points of intersection of the straight line cutting plane with the base of the solid. So we have obtained that as we are going to move from point 5 to 6, so at this much distance from point 5, so Q point will be located over here. Similarly, at this much distance from point 8, as we move along point 8 to point 9, now point Q1 will be located over here between the points 8 and 9. So we have marked these points Q and Q1 over here. So once we obtain these 2 points into the development surface view. Now we are going to join these artificial generators, that is additional generators, using the black color line over here. So these are 2 points of intersection which we have obtained onto the development surface view, and these points, they happen to lie onto the base. Now the next 2 points of intersection corresponding to the straight line auxiliary inclined plane, they happen to be phi 1 dash and 9 1 dash. So these 2 points, phi 1 dash and 9 1 dash, they happen to be the points of intersection corresponding to the intersection by this auxiliary inclined plane with the apparent lengths of the slant generators O dash phi dash and O dash 9 dash over here. So phi 1 dash point lies onto the slant edge O dash phi dash, whereas 9 1 dash point of intersection, it is corresponding to the point of intersection of the cutting plane and the apparent length slant generator O dash 9 dash over here. So now if we obtain these two radii from O dash to phi 1 dash and O dash to 9 1 dash, so this distance will represent apparent length of the radii corresponding to the points phi 1 dash and 9 1 dash. But onto the development, we need to obtain the true length of all the distances over here. So now from the points phi 1 dash and 9 1 dash, we have drawn a horizontal projector line onto the true length of the slant edge, that is O dash 1 dash over here. So this transformation from phi 1 dash 9 1 dash onto the true length projection over here will provide us with the true length of the radius onto the slant edge over here. So this radius now we are required to plot, that is O dash phi 2 dash and O dash 9 2 dash over here. So once we measure the distances O dash phi 2 dash and O dash 9 2 dash, now onto the generators O5 and O9. This is generator O5, this is generator O9. So onto these two generators, if we mark the same distances over here, so we will be able to obtain the 2 points of intersection 5 2 and 9 2 onto the slant generators O5 and O9 respectively. Now the next 2 points of intersection corresponding to the straight line auxiliary inclined plane with the apparent length generators O dash 4 dash and O dash 10 dash over here. So these are two generators which are being intersected at this point. So corresponding points of intersection happen to be 4 1 dash and 10 1 dash. So once we measure this radius O dash 4 1 dash, O dash 10 1 dash, so again the apparent length of the radius we are able to obtain over here. So how do we obtain the true length of this radius? From the points 4 1 dash and 10 1 dash, we are going to draw again horizontal projector lines and project this distance onto the true length, so that the true length of the radius can be obtained on the true length slant generator O dash 1 dash over here. So this point of intersection provides us with the location of the points 4 2 dash and 10 2 dash. So now we will be measuring this distance O dash 4 2 dash and O dash 10 2 dash over here. So now this distance we are going to plot alongside the slant generators O4 and O10. So this is slant generator O4, this is slant generator O10. So now once we mark the distance onto these two projector lines, now the points 4 2 onto the slant generator O4 and point 10 2 onto the slant generator O10 has been obtained over here. Now the next 2 points of intersection of this straight line cutting plane with another apparent length of the slant generator O dash 3 dash and O dash 11 dash. So this point of intersection we are going to obtain as 3 1 dash and 11 1 dash. So 3 1 dash point of intersection will be available on the apparent length of the slant generator O dash 3 dash, whereas 11 dash point of intersection will be obtained on apparent length corresponding to the slant generator O dash 11 dash over here. So now again, this radii which we are going to obtain corresponding to these 2 points of intersection, that is O dash 31 dash and O dash 11 dash. Again, this will represent the apparent length of the radii. So let us evaluate true length of the radii corresponding to these 2 points of intersection. So again, from the points 31 dash and 11 dash, we are going to draw horizontal projector line onto the true length of the slant edge O dash 1 dash over here. So this point of intersection will provide us with the location of the points 32 dash and 11 dash into the front view projections over here. So now we will be measuring the distance O dash 32 dash and O dash 11 dash as true length of the radii corresponding to the points 31 dash and 11 dash over here. So now once we measure this distance over here, so this distance we are going to plot onto the slant generators O3 and O11 over here. This is O3 generator, this is O11 generator. So once we mark these 2 points over here, so 32 point into the developed surface view and 11 point into the developed surface view have been obtained over here. So all the 8 points of intersection corresponding to the straight line cutting plane, they have been obtained. And now we can check points 31 dash and 11 dash. They are common to circular cutting plane as well as the straight line cutting plane. So the 2 points corresponding to the circular cutting plane have also been obtained simultaneously. Now, as we proceed in this direction, what are the next 2 points of intersection? So we can check this circular cutting plane. It also intersects with the apparent lengths of the slant generators O dash 4 dash and O dash 10 dash over here. So the 2 points of intersection earlier we had obtained, they were 41 dash and 10 dash, and their true lengths they were evaluated as 42 dash and 10 dash. So since it is again being intersected, that is the 2 generators O dash 4 dash and O dash 10 dash, they are again being intersected by the circular cutting plane. Now the points of intersection we have named as 4-3 dash and 10-3 dash over here. But again, these radii obtained corresponding to these 2 points of intersection onto the apparent length of the slant generators. So they will represent apparent length of the radii. So now let us transfer these 2 radii onto the true length over here. So from these 2 points 4-3 dash and 10-3 dash, again a horizontal projector line has been drawn onto the true length of the slant projector O dash 1 dash over here. So this point of intersection is obtained as 4-4 dash and 4-10 dash. So now once we measure this radius starting from O dash up to this point of intersection, so we will be able to obtain the radius corresponding to 4-4 dash and 4-10 dash. So now the circular cutting plane points we have marked as red color points, whereas the straight line points of intersection we had marked with blue color. So now onto the slant generators O4 and O10. This is O10, this is O4. Again 2 points of intersection here we are going to plot corresponding to the radius O dash 4-4 dash and O dash 10-4 dash over here. So the corresponding points 4-4 and 10-4 they have been obtained onto the slant generators O4 and O10 over here. Now the next 2 points of intersection by this circular section plane and the slant generators apparent lengths O dash 5 dash and O dash 9 dash over here. So they will be 5-3 dash and 9-3 dash, because this is the second intersection of the generators O dash 5 dash and O dash 9 dash with the cutting plane. Earlier it was straight line cutting plane, now it is the circular cutting plane. Again these 2 radii, they will be the apparent length radii from the point O dash over here. So once again we have drawn horizontal projector line from the points 53 dash and 93 dash over here onto the true length of the slant edge O dash 1 dash. So now these 2 points will be obtained onto the true length as 54 dash and 94 dash, and this radius we are going to measure now. So once we measure this radius O dash 54 dash and O dash 94 dash over here, so the 2 points 54 onto the generator O5 and 94 point of intersection onto the slant generator O9, they have been obtained over here. Now the next 2 points of intersection of the circular cutting plane and the apparent length of the slant edges O-6 dash and O-8 dash over here. So they will be 6-3 dash and 8-3 dash. Now we can check. I could have marked these 2 points as 6-1 dash and 8-1 dash because now these slant generators O-6 dash and O-8 dash, they have not been intersected previously by the straight line inclined plane, but we want to maintain the parity over here. All the points lying over here, they will be marked as 6-3 dash and 8-3 dash over here. So that is why suffix 3 we have used over here. But again, the radii corresponding to O-63 dash and O-83 dash will represent the apparent length of the radii. So now these apparent length radii, they have been shifted onto the true length. Now this true length is also there, O-7 dash. So rather than shifting it over here on the left side, now we have shifted these 2 points onto the right hand side because there are too many points already available on the left hand side. So from 6-3 dash and 8-3 dash, again a horizontal projector line has been drawn onto the true length of the slant edge O-7 dash over here. So now the true length corresponding to the points 6 and 8, that is O-64 dash, O-84 dash, they have been obtained. So now onto O6 and O8 generator. So this is O6, this is O8. Another couple of points we have obtained. So these points, they happen to be 6, 4 and 8, 4 over here. Now the next point of intersection of the circular sectional plane with the true length of the slant generator O-7 dash happens to be the point, this one, 7-3 dash. So now we need to measure the distance of the point 7-3 dash from the O dash. Now we need not obtain 7-4 dash. Why? Because this point 7-3 dash itself is lying upon the true length of the slant generator O-7 dash over here. So once we measure this radius O-73 dash, now onto the slant generator O7 in the developed surface area, if we mark the same radius over here, so we will be able to obtain the point 7-3 into the developed surface view over here. So now all these points of intersection, that is 8 points of intersection alongside this straight line auxiliary inclined plane and 7 points of intersection alongside this circular sectional plane over here. So total of 15 points we have been able to plot over here. So once we join all of these 15 points into the developed surface view over here, now we will find that this portion of the cone has been cut over here. So we can join the remaining portion of the cone over here. So these are the base points which have not been intersected by the cutting plane. And now O1 also we can join because we can check O-1 dash has not been intersected by this cutting plane over here. So this is how we are able to obtain the development of the lateral surface of the truncated cone, which has been intersected by 2 cutting planes over here. So this is how we are able to obtain front view projections of the truncated solid, the top view projections of the solid, and the development of lateral surface of the truncated cone, which has been cut by 2 cutting planes over here. So we are going to continue with further discussion regarding few more illustrative cases of development of the lateral surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.